Welcome to chapter 4 of Pure Mathematics 1, and we are going to learn graphs and transformation. And to start with, we need to just understand something about cubic graphs. And we must be advised that the general cubic graph is of this form: ax cubed plus bx squared plus cx plus d. Of course, where a, b, c, and d are real numbers, but there is only one rule in this: a is not supposed to be 0, because if it was 0, then the whole of the first term ceases to exist, and the whole of the function is no longer a cubic function. What is the general shape of a cubic function? A general shape of a cubic function is of that format. It can be having this shape or this shape. You would see that it has a maxima followed by a minima, or we can even start with a minima followed by a maxima, or any other shape. You're going to see other shapes as we move forward. And if P is a root of the cubic function, then the graph cuts the x-axis at the point P0. That could be P1, 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 0. We could have P2, 0 coordinates. This is another point P3, 0, where P1, P2, and P3, all of them are roots of this cubic function y is equals to fx, where fx is a cubic function. Having said that, I think it is important to go to example 1. And in example 1, we are expected to show something. Sketch the curves with the following equations and show the point where they cross the coordinate axis. Let's just have example 1 here. And example 1, part A. Example 1, part A. We have the graph of y is equals to x minus 2, x minus 2, 1 minus x, and 1 plus x. Surely this is a cubic function, because if you open the bracket, you'll have x times x times x. You'll surely have x cubed. But of course, if you look at this function, it's already finalized into 3 brackets, and therefore the solutions to every function only appears when y itself is equals to 0, or rather along the intercept of the x-axis. So if you want to find the critical values of this cubic function, we must assume that we have x minus 2, 1 minus x, 1 plus x is equals to 0, so that we can solve the critical values. So any of this bracket can be 0, because if any one of them is 0, then the product is 0. If x minus 2 is equals to 0, then x is equals to 2. If 1 minus x is equals to 0, then x is equals to 1. And if 1 plus x is equals to 0, then it follows that x is equals to negative 1. And these are what we are calling now the critical values, or the roots of the cubic function. That means that cubic function, this cubic function, cuts the x-axis at 2, 0, at another point 1, 0, at another point negative 1, 0. That's where it cuts the x-axis. So we can easily sketch this graph, and we have negative 1, and we have positive 1, and we have positive 2. These 3 points are some of the points through where the graph passes. But sketching is about the shape. So we need to understand what is the shape of this particular function graph. And we cannot know the shape if we did not understand how the graph behaved when before we talked about the least value of x, which is -1. And we only need to understand as x approaches -infinity, and in this case, -infinity is starting from the left of -1, and in this case, x can be -2. We want to see how y behaved when x tends to be -infinity, and you are going to see right now. So what? Below -1, we have x being equals to -2. And when x is a -2, it follows that this bracket becomes -2 minus 2, -2 minus 2. The second bracket, 1 minus -2. The third bracket, 1 minus plus -2, that means -2. And this bracket is -4. This one is 3, and this one is -1. And you can see this is a positive 12. So as x approaches -infinity, y approaches positive infinity. So as x approaches -infinity, y approaches positive infinity. So this graph is coming from this end. This graph is coming from this end. But let us examine as x approaches positive infinity. What happens to y? Positive infinity, it means now x has to be one value above the maximum root, which is a 2. And let's say in this case, one step above the maximum root is obviously a 3. And 3 minus 2 is a 1, multiplied by 1 minus 3, which is a -2, multiplied by 1 plus 3, which is a 4. And you can see this one gives you 3 minus 2 is 1, 1 minus 3 is -2, and 1 plus 3 is 4. This one gives us -8. So you can already see as x tends to be positive infinity, y approaches negative infinity. What does this mean? As x approaches positive infinity, y approaches negative infinity. So as much as x is going further from 2, y is sinking further to the negative. That means the way we explain here, easily the shape of our graph is simply that. But it is part B that we must concentrate on. It is part B that we must look at with a very keen eye. And part B is talking about y is equals to x, open bracket, x plus 1, x plus 2. Already, without further ado, you can already see the critical values. This one is a bracket which is quite independent. So x can be 0, x can be -1, or x can be -2. So before we go anywhere, let us highlight the critical values: 0, -1, and -2. That is 0. These are the roots of this cubic function. And we need to understand, as x approaches negative infinity, how does y behave? Negative infinity starts from -2 to the left. That means x is going to be -3. This bracket gives us -3. The second bracket gives us -3 plus 1, -2. The third bracket gives us -3 plus 2, -1. Of course, you can see all this is negative 6. So as x approaches negative infinity, y approaches negative infinity. So as x approaches negative infinity, y approaches negative infinity. Let's see. As x approaches positive infinity, how does y behave? Positive means a value of of x needs to be something greater than 0, and the next value is just 1. So what does the first bracket give us when we have 1? It's a 1. The second bracket, 1 plus 1, is a 2. The third bracket, 1 plus 2, is a 3. And we have a positive 6. So as x approaches positive infinity, y approaches also positive infinity. So as x approaches positive infinity, y approaches positive infinity. So our graph, as much as it is passing through that point, and through this point, it's having a shape that looks like that. So this part of identifying the shape of the cubic function is very, very important. So don't forget to evaluate the shape by considering x tending to be negative infinity. How does the graph behave? Then positive infinity, how does the graph behave? All right?